4.3 Lesson 2, Derivative of a Quotient of two functions. Our objective for today is you'll be able to use the quotient rule to prove the differentiation rules for these trigonometric functions. F of x is equal to tangent of x. So how can you use the quotient rule to differentiate tangent of x when tangent of x is not a quotient? Well, you could write tangent of x as a quotient by using a fundamental trigonometric identity called a quotient identity. So f of x, you can write that as f of x is equal to tangent x. You can write that as tangent can be written as sine over cosine. So now you have a quotient, so you can find the derivative of tangent x using the quotient rule by first rewriting it as sine x over cosine x. And then you can rewrite f of x is equal to cotangent of x using a fundamental trig identity as cosine over sine. So now it's written as a quotient, so you can find the derivative of cotangent by using the quotient rule. And what about secant x? You can write secant x using what we call a reciprocal identity. Secant is the reciprocal of cosine, so you can write that as 1 over cosine x. And now you have secant written as a quotient, so you can use the quotient rule to find the derivative of the secant function. And the same for cosecant. You can write cosecant of x using a reciprocal identity as 1 over sine x, and 1 over sine x is a quotient, so now you can go ahead and use the quotient rule and find the derivative of cosecant. So that's what we'll see. Once we apply the quotient rule to each of these four functions, we will get the derivative of each of these four functions, and we'd like to simplify each derivative so that it's in a particular form that everybody has agreed to as the conventional form for the derivative for each of these four functions. So our objective, once again, is to use the quotient rule to prove the differentiation rules for these four functions. When we are done, we will see that the derivative of the tangent function is secant squared x. The derivative of the cotangent function is negative cosecant squared x. The derivative of the secant function is secant x times tangent x, and the derivative of the cosecant function is negative cosecant x times cotangent x. So now let's look at these individually, and we will start with tangent. We'd like to find the derivative of y is equal to tangent x. So our first step is to rewrite the tangent function using a trig identity. It's a fundamental trigonometric identity called the quotient identity. You can write tangent x as sine x over cosine x. And now tangent x is written as a quotient of two differentiable functions. So we may, of course, use the quotient rule to find the derivative of the tangent function. So we set it up. Y prime is equal to the denominator times the derivative of the numerator minus the numerator times the derivative of the denominator, all over the square of the denominator. So now we'll go ahead and differentiate. So we have y prime is equal to cosine x times the derivative of sine x, which is of course cosine x, minus sine x times the derivative of cosine x, which is negative sine x. So you have times negative sine x all over cosine squared x. So we can simplify. So we have cosine times cosine, which is cosine squared x, minus negative sine squared x, which is, of course, plus sine squared x. All of that will be over cosine squared x. So we're done with the differentiation. This is, in fact, the derivative of the tangent function. But if we're going to be using the derivative of the tangent function again and again to do problems, we'd like to simplify the answer. So there is another identity called a Pythagorean identity, and that Pythagorean identity is if you have sine squared x plus cosine squared x, that is equal to 1. And we're going to use the Pythagorean identity to rewrite the numerator as 1. And of course, 1 over cosine squared x, you can write that as 1 over cosine x times 1 over cosine x. And 1 over cosine x by the reciprocal identity is secant x. So this is secant x times secant x, which of course is secant squared x. So the derivative of the tangent function is secant squared x. And of course, that is what we have here. The derivative of the tangent function is secant squared x. We used a Pythagorean identity in our work. Now we will take a look at how to find the derivative of the cotangent function. Our first step is to rewrite the cotangent function as a quotient using a quotient identity from trigonometry. Cotangent can be written as cosine over sine. So now that we have a quotient of two differentiable functions, to find the derivative, we may use the quotient rule, and we write y prime is equal to the denominator times the derivative of the numerator minus the numerator times the derivative of the denominator all over the square of the denominator. So now we go ahead and follow through, and we have sine x, the derivative of cosine x. The derivative of cosine x is negative sine x, and then I have minus cosine x times the derivative of sine is cosine. All of that over sine squared x. So now I have y prime is equal to, in the numerator, sine x times negative sine x is negative sine squared x, and then I have minus cosine squared x over sine squared x. And again, this is in fact the derivative of the cotangent function, but if we're going to use a differentiation rule again and again, we'd like to have it in simplest form. So we want to simplify our answer, and we see that in the numerator we have negative sine squared x and minus cosine squared x. So we think maybe we can use our Pythagorean identity here. But before we can do that, we have to factor out a negative 1 from each term in the numerator. So when we do that, this is what we have. And of course now, in the parentheses that you have here, that is the left side of the Pythagorean identity, and you can replace that with 1. So you get negative 1 over sine squared x, which you can of course write as negative 1 times 1 over sine x times 1 over sine x. And 1 over sine x by a reciprocal identity is cosecant x. So you have negative 1 times cosecant x times cosecant x, or negative cosecant squared x. And that is in fact the final answer. I'm running out of room, so I'm just going to sort of draw a green arrow there and write negative cosecant squared x is the derivative of cotangent x. And of course, we have that right here. The derivative of cotangent x is negative cosecant squared x. Now we look at the secant function. We'd like to find the derivative of y is equal to secant x. And the first step is for us to rewrite the secant function using a reciprocal identity from trigonometry as 1 over cosine x. So now we have a quotient, and we may use the quotient rule to find the derivative. So we write the denominator times the derivative of the numerator minus the numerator times the derivative of the denominator all over the square of the denominator. So now we have y prime is equal to, in the numerator, we have the derivative with respect to x of 1, which is 0. Cosine x times 0 is 0. So you just write 0 minus 1 times the derivative of cosine, which is negative sine. So minus negative sine is plus sine x. So in the numerator, you just have sine x. 0 plus sine x is just sine x. And in the denominator, you have cosine squared x. So we're done. We have found the derivative of the secant function. But again, you'd like to simplify this because you plan on using this differentiation rule again and again. So how can we simplify? We write y prime is equal to sine x over cosine squared x. You can write that as cosine x times cosine x. And you can write this as 1 over cosine x times sine x over cosine x. So what we have is a product of two fractions. So when you multiply the numerators, you get sine x. When you multiply the denominators, you get cosine x times cosine x. And the first fraction by a reciprocal identity is secant x, and the second fraction by a quotient identity is tangent x. So the derivative of the secant function is y prime is equal to secant x times tangent x. And of course, we see that here. So now we take a look at the derivative of the cosecant function, and our first step is to write the cosecant function as a quotient of two differentiable functions. So we can write cosecant as 1 over sine x using a reciprocal identity from trigonometry. Now that we have it written as a quotient of two differentiable functions, we may use the quotient rule to find the derivative. So the derivative is equal to the denominator times the derivative of the numerator minus the numerator times the derivative of the denominator all over the square of the denominator. So now we just follow through. So the derivative of the constant 1 is 0. So you have sine x times 0, which is of course 0. So I can just write 0 minus 1 times the derivative of sine x, which is cosine x. So 1 times cosine x is cosine x. So I have 0 minus cosine x in the numerator. 0 minus cosine x is negative cosine x. And in the denominator, I have sine squared x. And again, I am done. I have found the derivative. But if I want to continue using the differentiation rule for cosecant again and again, I'd like to simplify it. So how can we simplify this? We can write negative 1 over sine x times cosine x over sine x. So we have a product of two fractions. So you multiply the numerators, and that gives you negative cosine x. You multiply the denominators, and that gives you sine squared x. And of course, for the first fraction, you have negative 1 in the numerator. So you can see it this way. So you have a factor of negative 1 and then 1 over sine x, which is, of course, cosecant x. So that gives you negative cosecant x. And for the second fraction, using a quotient identity from trigonometry, we know that cosine over sine is cotangent. And now we have simplified the derivative for the cosecant function. The derivative of cosecant x is negative cosecant x times cotangent x. And of course, we see that right here. The derivative of cosecant x with respect to x is negative cosecant x times cotangent x. So in this lesson, we use the quotient rule to find the derivatives of the tangent, the cotangent, the secant, and the cosecant functions. In doing so, we had to use what we knew about the derivatives of the sine and the cosine functions, the quotient rule, and some fundamental trigonometric identities.